I'm a big believer in drawing pictures. I think that it makes a big difference in how you attack the question, and it allows you to perhaps break the problem up into the parts that you're looking for. Now, you're not going to be required to draw any pictures on this next test, but the one after that you will. So I would encourage you to start getting used to just sketching a quick picture. And in the pictures that I tend to draw, I don't know if you've noticed, but I tend to try and put, I try to put things together in like an order. So there's the ball that's just been hit. What the heck is that? The ball's just been hit, and it's going to go straight up. And we're told that the ball, oh, they updated the app. I don't like that. The ball goes 125 meters into the air. Now, it says reaches a maximum height. That's kind of important because at the max height, the final velocity is 0. It's funny the things that you have to know for my class, because it doesn't seem like they're like, definitions, but you should know that the maximum of something that's attained usually is attained when something is a 0. In this case, the maximum height is attained when the velocity is 0. If it still had an upward velocity, it wouldn't be at the maximum height. And if it had a downward velocity, it will have already left the maximum height. So when the velocity is 0 for that split second at the top, that's the maximum height. So that gives you a piece of information. And the ball's not going to go any higher than that, so my picture really has drawn just the first half of the ball's motion. You figure the ball's going to leave the bat, make it up here, and then eventually come back down. But I see this as two different problems. The first question says, what was the initial velocity of the ball? I think I have enough information to solve that. First, let's identify what I'm going to be looking for. I'm going to be looking for the variables associated with the ball's trip upwards, meaning I'm only interested in the first half of the ball's motion for this question. Final velocity is 0 for that trip. Initial velocity is unknown, and that's actually what we're being asked to find. Now, before I do any of the other values, because they are values, I want to identify what direction we're going to call positive. And it makes no difference to me whether we call up positive or down positive. You have a tendency to want to do the same thing every time, and I would encourage you to break away from that pattern. We will eventually have problems where up and down is meaningless. So don't be attached to up being positive all the time. You'll get into a habit, and that habit is hard to break. So I'm going to purposely make down positive for this question. It will make no difference in the answer. I will say, though, that by making down positive, the ball went upwards 125 meters. So I make its displacement negative 125 meters. The acceleration is the acceleration of gravity, which is acting downwards at 10 meters per second squared. So that's positive 10 meters per second squared. Those are the 4 things that are of interest in this problem. Yeah?
On the test, we use 10 or we use 19?
We use 10.
Yeah.
We use 10 for everything. Part of the reason I don't use mastering is mastering uses 9.8, which is ridiculous. And the AP exam allows us to use 10. And let me just have a, is this actual coffee or did my daughter screw up? No, that's fine. Let me just kind of attack something really quick. I've worked with a lot of peers who essentially require that everybody use 9.8 because they say it makes their numbers more accurate. It's a bit of a ridiculous thing to say. 9.8 might be closer to the reality. Actually, in this classroom, we tend to never measure anything more than about 9.6 or 9.7 because of the air resistance. When you're working out the numbers, you're off by about 2 to 3%, right? Comparing 9.8 with 10, there's a 2% difference. It's like comparing 98 with 100. So your values are about 2% off, but all the numbers are made up. The problems aren't about the numbers. The problems are about the procedure. So you are free to use 10 because the AP exam doesn't care about whether you know that it's 10 or 9.8. They'd like you to know that there's a difference. We use 10 because it makes the numbers easier to work with, because the arithmetic is the least interesting and the least important part of all the things we do. I mean, we're about to do the most important part of all of this. After this, there's really nothing that's important, worth 1 point if this was a problem. Because to me, we've done the hardest part. You've identified all the things that are appropriate with this problem. I say you, but it was me. We identified a direction that we call positive. We've evaluated the direction for each of the vector quantities and assigned them a positive and a negative. Now, if you haven't been writing that down as a series of steps, I don't know what you're waiting on. I don't write steps down. This is a college class, but if you haven't noticed, I've done these problems the same way every time we've talked about them. I draw a picture, I identify direction for positive, I write out the motion variables, I attempt to assign the values to the appropriate motion variables, and then I evaluate those values for whether they should be positive or negative. You want me to say all that over again? Because I see you all busily writing. So I draw a picture, and my picture attempts to show the events. I identify what direction is positive on my picture. I write out the motion variables. I attempt to apply positive and negative to the vector values. These are the hard parts of the problem. Wrapping your head around and what you're going to do, I mean, that's the hard parts. Now, at this point, I need to identify what it is that I wish to solve for and then choose a direction to solve for it. This problem is an exercise in that I can do this in a single step with a single equation by plugging and chugging. But deciding how you're going to solve, that's generally a challenge, especially for ones that aren't so clear-cut. But I'm going to identify one of the relationships by looking at the 5 relationships, and I'm going to choose the one that has the 4 important variables in it. This will be the one that does not have time in it. So for me, that's going to be v final squared minus v initial squared equals 2a delta x. So 0 squared minus v initial squared equals 2 times 10 times negative 125. I know you guys love to jump to your calculator, but this part, the arithmetic, is worth a point. That's it. It's the least interesting thing. And I'd encourage you to use your calculator the least amount possible. It tends to get in the way more often than it's helpful. 2 times 125 is 250. 10 times 250 is 2,500. And I can cancel out the negative signs. So 2,500 equals vi squared. To me, here is the only time that a calculator is probably necessary to give you an opportunity to take a square root. So I will remind you, though, when you take the square root, always remember to evaluate whether it's plus or minus. So what is the square root of 2,500? So when I write my answer, I'm going to say 50 meters per second, and I'm going to choose to say upward. I could put minus, but this problem can't tell me the direction of the velocity. I have to make a decision. So if you're thinking about like what your like how I'd grade this test, there'd probably be one point for the correct answer with its direction and unit. 1 point for choosing the appropriate relationship. 1 point for a correct application of direction applied to all of the variables. And 2 to 3 points for correctly identifying the information in the problem. So when you look at this, I want you to understand that partial credit is assigned based on meeting certain milestones. And those milestones are related directly to what I feel are appropriate use of what we've talked about in class. The number answer, the least interesting part of the whole thing. Now this problem has a second part. So to handle the second part, I'm just gonna slide that off to the side because I'm not sure I need all of it, but I need some of it. I'm gonna change some of the things that are here though. They want the time that the ball is in the air. That's a different question than what we just answered. The time the ball is in the air isn't the time till it reaches the highest point. It's the time till it comes back to where it started. So you have probably more than one way you could attack this problem. The shrewd kids in the room probably realize you could just solve for this time right now and double it. Whatever time it took to get up, probably takes the same amount of time to get back down, and you could double it. But that's making an assumption. And instead of making an assumption, we're gonna do the problem more holistically. To do the problem holistically, I'm gonna recognize that delta x isn't negative 125. Delta x is 0. Now, I can't use the final velocity being 0, but I can use the fact that the initial velocity was negative 50 meters per second. I'm doing a different problem, and in this case, I am using something I solved for in part A. I generally shy away from that when I can, but I'm gonna use it this time. Now, since this being a part B of the problem, I probably would not give you the same number of points for your picture and such. I would give you points for recognizing that this problem is asking something different and changing the variables to reflect what the new problem is about. 1 to 2 points, perhaps. I don't need final velocity, so I am interested in the 4 motion variables that are presented there. So I'm going to use delta x equals 1/2 at squared plus v final times t. This has everything in it except for final velocity. Delta x is 0 equals 1/2 times 10 t squared minus 50 times t. And I think that you guys can probably do the rest. The fact that I see you guys hurriedly writing suggests that you didn't do this question when you were asked it in class, but probably you ran out of time. The 2 tests together were probably too much time for what you had available. 1/2 of 10 is 5, and I can factor out of 5, so I will get 5t times t minus 10 equals 0. This gives me 2 answers for t, and it's appropriate for me to choose the correct one. All right. Yes, sir?
At the top, that's it's supposed to be an I, right?
Yes, it is. All right. I assume everybody has access to the test. I'm going to just sketch real quick what the graph looks like. Four and negative 14. And this is 3 seconds. And we don't have a precise location for the 0, so I can't mark it. But we can do the rest of this problem. This is not terrible. So you're first asked to sketch a position graph. So I'm going to just look at that graph and realize that the area of the graph that's down here is bigger than the area of the graph that's here. So it traveled in the positive direction much less than it traveled in the negative direction. But I don't know exactly where this is. Remember, this is just a sketch. So because I don't have as precise information, I could find out all that information, and I believe all of you could too. But I want to show you how you could do this without having the precise information. We're supposed to start at the origin. So I will start at the origin, label this position, put it in meters, label this time, put it in seconds. Those are easy points. Don't lose them. Okay? Even in this one, I would have expected to see the labels. The graph starts with a positive velocity. So my graph over here must start with a positive slope. Now, it looks to me like somewhere just before 1 second. So if this is 3, 2, 1, somewhere just before 1 second, the object has a velocity of 0. So, and it's traveled some positive displacement. So I'm thinking there's got to be a point right around there. And that point has to have a velocity that is 0. So I'm going to make a little sketch like that. Yes, sir? I couldn't hear you. Say that again. Not here, because it's right on the 0 for velocity. So at this instance, the velocity is 0 for that instant. So the slope here is flat. Does that make sense? Now, down here, yeah, it's going to be a negative velocity. So from this point forward, the slope of this line is always going to be negative. And more importantly, the slope of this line is going to be becoming a steeper and steeper negative number. So, in fact, I'm going to have to put a point down here like at 3 and state that it's got a steeper slope here at 3 than it had to start. Now, you got to connect it together. Now, you're right, I don't have a number to put here. And I don't have a number to put here. To do that, I would actually have to find out information about the motion of the object, which you have tools to do now. So, for example, I could find out the total displacement. That would be pretty easy. I've got delta x equals 1/2 v initial plus v final times t. This is a trapezoid. Even though it's folded over, I could treat it like a trapezoid. So this would be 1/2 4 plus negative 14 times 3. So that's negative 10, half negative 10, negative 5, negative 5 times 3, negative 15. So the displacement was negative 15 meters. That means this point, negative 15. I don't know where this is, but I'm sure I could find it if I wanted to. In fact, I think that there's other things we could do here, but I want to stop for a minute. This is the answer to the question. Is there something else you'd like me to do for this question? Later on, you're asked to write a mathematical model. There are 2 equations out of the mathematical models. I've tried to say this to you, but I'm just going to be super explicit. The models are what we see in our graphs. So this model has to be linear, and this model has to be quadratic. The whole lab was about applying models to the problems. Now, if you look across your 5 motion equations, there's only one that is linear. And there's only one over here that is quadratic and uses initial information. Those are our models. When you're asked to make a model of one of these graphs, you're looking to do these 2 things. Now, in both cases, you need the acceleration. But we know the acceleration is just the slope of the graph. So I can find the slope real quick. I have this point and this point. So let's find the slope. It's final, negative 14, minus initial, divided by the time. That's negative 18/3, or negative 6 meters per second squared. So if I wanted the linear model, if I wanted the model for the velocity graph, That would be negative 6t plus 4. And if I wanted the model for the position graph, that would be 1/2 negative 6t squared plus 4t. Those are the models. Now, we did this like, I think, 1.5 times last night. But you weren't, I'm not saying that I won't do it. There, a drive is inclined. And it says that is inclined in such a way that a rolling object's acceleration downward at 0.5 meters per second squared. This driveway has seams that are 2 meters apart, and you watch a ball roll from somewhere above the first seam, and it takes 0.5 seconds to travel between the seams. How far above the first seam did the ball begin its roll? And I spelled seams wrong in one of those. I did S-E-E-M-S when it should have been S-E-A-M-S. So thank you, autocorrect, for not knowing what the hell I was talking about. But hey, there it is. So, oh, and I got a bad word going on the video. Yay! Don't let your parents listen. There's some seams there, and they are 2 meters apart. That's why I say it's not for kids. I say bad things. I'm gonna get fired eventually. Maybe not today. The ball is started up here, and we are told that the ball will accelerate down the ramp at 0.5 meters per second squared. We don't know how far above the first seam the ball was released, but we do know the ball was released here from rest. There, that's all the information we have. Oh wait, we have one more thing. The ball traverses the distance between the seams in 1/2 second. All right. I have to make a decision on what direction I will call positive in the problem. And you guys are excellent at not writing down the things that I'm saying in class. I mean, some people just read books in class, not calling them out, but they're right in the front row. Wow, that's powerful. And I'd say it requires a lot of courage. This might be how I get part of my reputation, but I think that was fair. I draw a picture, and I think the picture is something I would encourage you guys to do. It's not required for tomorrow's test, but you will be having to draw pictures on other tests. One of the things that I want the picture to convey to me are the parts of the problem, and to convey to me the direction that we're going to call positive. You need to choose a direction that you call positive, and don't be complacent about this choice. Take a measured thought about it, because as you apply this later, this is worth worth credit to the problem. The first thing I recognize is that this problem seems to be broken up into 2 parts. There's the part of the ball's motion that's before the first seam, because there's a displacement there that I'm trying to find. So if I consider that displacement and the information presented therein, I would have a group of 5 motion variables related directly to the ball before it makes it to the seam. And then I have a group of motion variables that I feel is related to the ball after it passes the first seam. Bless you. Now, the reason I'm talking like this is your job is to wrap your head around the question in some way. So the next thing I think you should do after you choose direction is consider a set of motion variables and how you would apply them to the portions of the problem you're seeing. Now, I'm not writing these steps down anywhere, but this is what I think you guys should be writing down. Once you write out the motion variables, you need separate motion variables for each acceleration, separate motion variables for each period of time, separate motion variables for each acceleration. Whenever there's a change or a different event, you would need separate sets of motion variables. These events might be tied together in some way, but you need to understand when another set of motion variables is necessary. In this case, because there's 2 separate displacements, and I only have the time for one of them, that necessitates 2 different sets of motion variables. Now, the next thing I will be looking for to score you on is, did you take the information presented and organize it correctly? So I'm specifically looking to see that you go, okay, this is 2 meters, and the acceleration is 0.5 meters per second squared. It's a lot of sneezing. And the time is 0.5 seconds. and then evaluate direction. Now, I know you guys think that I've already done that, but I haven't. I am very explicit about evaluating direction and place positives or negatives depending on the direction of the things that are vectors. 4 of the values are vectors. If you, on your test, write all the information out and you apply direction correctly by putting a positive sign or a negative sign, then you are articulating to the test grader that you took the time to think about what direction each of those vectors should be. There's some real value there because eventually there's going to be math here, but the math is worth the least amount of points. I give points for your organization of the data that's presented. And we'll go back through the point totals that I would probably assign to this problem in a minute. All right, so next I am going to look at the other portion of the problem and notice that I have an initial velocity here that is 0. And it also has the same acceleration, 0.5 meters per second squared, because it's on the same incline, and it too is positive. But that's the limit of the information that I have. And now I think this part is probably one of the more crucial parts, but you guys tend to skip it. What is it you want out of this problem? For us, it's this displacement. How far above the first seam was the ball released? That's this value. Now, the only way I can determine this value is if I've been given 3 pieces of information related to these motion variables, and I haven't. So you need to find a way to use the information that's been given to get you another motion variable over there. And there is something. If you've been paying attention in class, I've made this pretty plain. The ball rolls to this point, and a bunch of you have figured this out. When the ball makes it here, it has some velocity here. That velocity is the initial velocity for this interval and the final velocity for that interval. That's how these 2 intervals are connected together. When a ball hits that seam, they are joined by this value. If I can figure out this value on one side, I can use it on the other. And since I have 3 pieces of information here, then I can find that value with the information on the left side and plug it in on the right side. Doing something like this on your work tells the test grader that you have come up with a plan and you recognize how the different things of this problem, all the different parts of this problem are related. This is worth valuable credit because the next part's worth a lot less credit than you might think. I need to figure out the initial velocity. That's the least interesting thing here. I look up on a note card, which I will allow you to have on the test, 1 note card with the 5 motion variables, 5 motion equations on it. You may have it for the test tomorrow. I will be signing them in class. And if yours has a signature on it when you start the test, then I will take it and rip it up, because that means you got it from somebody in first period. Does everybody understand? So you lose it and the person in first period loses it. Make your own. They've been on the board for a while. You should have access to them. Please write them down. Have them on the test. After this test, you will not be allowed to use a note card. I'll give you the equation sheets instead. But right now, the equation sheets are they're too distracting. There's too much stuff on them. Now, once you have the appropriate relationship down, plugging in and getting an answer is very, very boring and not worth very much by the way of credit. I mean, you need to do those things, but I'm not sure I need to see them. And once you have this value, you're going to need a relationship to use over here. Probably I'd use this one. Because that brings those 4 pieces of information together. And you'll be getting this value here and using it as your final value here. Now, I'm not going to solve the rest of this problem unless you desperately want the numerical answer. But I do want to speak to credit. You'll have to get the value for the velocity. That's going to be worth a point. And you will have to have chosen probably a correct formula to get there. And over here, a similar correct formula where you will eventually have delta x equals. These will all have to be an answer that has units and is expressed in the right direction. So if you want that point, that's how you get it. But identifying the data, 2 to 3 points. Since there's 2 sets of data, this might stretch to 4. Identifying the appropriate direction and applying it to all the vectors might be worth 1 point per set of motion variables. And organizing the data from the problem sometimes is also worth a point. Now, lastly, sometimes I offer a point for correctly choosing a direction for the problem. There's no correct way to choose the direction, but applying it to all the variables, that's what I'm looking for. So in a problem like this, 1 point for doing math, maybe 2. It's about the construction of the problem. What you identify from reading it, that's where you're going to get the bulk of your credit. So if you skip over those things because I can just do it in my head, you'll probably lose the credit. Especially if when you do it in your head and you get the number part wrong, you'll get a 0 because there's nothing there to back up your work. So I've given you a very solid framework. I am going to be using that framework in the grading of the test. And so if you want the person who's going to have your test to grade your test the easiest, provide them with all the information that you gleaned from the problem. Give them the framework. All right. Consider an incline like this. And there's a homework question kind of like this, number 2 and 1. They're kind of joined together. But let's say that the incline is not so terribly steep and causes an acceleration of 0.25 meters per second squared. And you roll the ball up this incline at 3 meters per second. And any number of questions could be asked here. So the simplest of it is, how far up the ramp does it roll? And it's a nice, simple question. It's an exercise. Now, in executing this question, you do have to make a decision on what direction will be positive. So this is a one-dimensional problem still, with this being the origin, but you can choose up the ramp or down the ramp to be positive. So which one do you guys want to choose? You want up the ramp to be positive or down the ramp to be positive? Good, so down the ramp is positive. I'm purposely choosing the opposite one you asked for to prove a point. All right? Because you probably wouldn't make this choice. And I want to prove to you it doesn't matter what choice you make as long as you make a choice and stick with it. Everybody understand? So I have my 5 motion variables. I believe the ball is going to make it to some position up here, which I'll call delta x, and we'll have some final velocity equal to 0. So I'm kind of completing the problem and completing my picture. Delta x is unknown, but the initial velocity is 3 meters per second. The final velocity will be 0, and the acceleration will be 0.25 meters per second squared, and I'm looking for this. Now, I need to apply direction. So any of the arrows in my picture that point downwards are positive, and any of the arrows in my picture that point upwards are negative. So I've applied direction to each of the vector values in my answer. So now I want displacement. I'm going to choose a relationship that has those 4 things in it. I'll be neglecting time, so that suggests I'll use v final squared minus v initial squared equals 2a delta x. So ominous. 0 squared minus negative 3 squared equals 2 times 0.25 delta x. The negative 3 squared is positive 9, but there's still a negative out front. So negative 9 equals 0.5 delta x. So delta x equals negative 18 meters. This negative means up the ramp. I chose negative to be up the ramp. My answer worked out to be negative. So it told me that the ball will go up the ramp 18 meters. Getting the negative here isn't wrong. It merely explains to me the direction of the answer. So I want to be very clear. It doesn't matter what direction you select as positive or negative. What matters is that you apply it correctly to each of the things that you can assign an arrow to. And you can assign an arrow to these 4 things. So when you do that, just be aware. But also be aware how this works. There are a number of students here who have issue with this. And so be careful. This negative sign that's here is explicitly in the formula. So don't think because the value is squared that would somehow take away that negative sign. It doesn't happen. But if there's a negative on the object, be aware that it's inside the value for the object. And when you square it, that makes it positive. I believe you know these things, but sometimes in the heat of a test, a reminder is not a bad idea. All right. Okay, so in this problem, the first rock is dropped. So let's just consider the first rock for a moment. In this problem, I think we can all agree it's a free fall question. It's gravity bringing the rock downwards, so the acceleration is 10 meters per second squared. This rock was released from rest at 0 meters per second and takes 2 seconds to reach the ground. We'd like to know how tall the bridge is. You guys stated that the direction up was positive, so my acceleration has to be made negative. Yep.
Is that only with free fall problems?
Which part?
The acceleration being negative?
No. It's free fall problems means the acceleration is 10 or 9.8.
Yeah.
The fact that it's negative is because we selected upwards to be positive and gravity is always downwards. So I'm going to strongly encourage you not to assume that gravity is negative 10 meters per second squared. I've never said that. I've said that gravity is 10 meters per second squared downwards. I've done so on purpose because G is going to show up in a lot of other places soon. So don't become complacent there. I can't tell you how often I have stressed, pick direction. So I'm going to use delta x equals 1/2 at squared plus vi times t. That's going to be equals 1/2 negative 10 times 2 squared plus 0. 2 squared is 4, half of 4 is 2, and 2 times 10 is negative 20 meters. So the bridge is 20 meters above the water level. Now, the next problem, and I have to hurry a little bit. If you haven't tried this problem, you're going to be surprised because I have expectations. In this next problem, delta x is negative 20 meters, assuming we keep upwards positive. The acceleration is still negative 10 meters per second squared, but the initial velocity is positive 10 meters per second. You need the time. Like I said, I have expectations, and here's my expectation. First, do I need to talk about where those values came from? So I don't need to picture anymore. This will be delta x equals 1/2 at squared plus vi times t. Now, just so you guys know, you don't have to do the problem this way. You could find final velocity and skip what I'm about to do. Because if you do the problem this way, negative 20 equals 1/2 times negative 10 t squared plus 10t. You'll have to solve this using the quadratic formula or factoring. I have no trouble with this, but I have found that students, once they leave algebra, are terrible at this. But this does not bother me in the slightest, and I have no trouble with it being on tomorrow's test because I'm supposed to be able to count on you guys knowing how to do this kind of stuff. This can't be factored, by the way. There are no 2 factors that will work here. So the only way you're going to do this is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I mean, I know my quadratic formula. I hope you guys do. And again, you guys tend to shove all that in your calculator, which is almost always to your detriment. Do a couple of steps. Uh, 16 plus 4 is 20. Square root of 20 is somewhere between 4 and 5. So I know that this is 2 plus or minus 4.6 something over 2. I would strongly encourage you, use your calculator as sparsely as possible if you have to do a quadratic. Now, I'm not trying to trick you. Do not expect this tomorrow on your test. I could easily ask it and not feel guilty, but I'm not going to.